Okay, so for number 5, the volume of an ice cream cone in the diagram below is 12 pi cubic centimeters. If the height of the ice cream cone is 9, what is the diameter of the opening? So what you need to do, the volume of a cone is 1/3 pi r cubed, pi r squared times the height. So if you know the volume is 12 pi, that's going to go in for V. You don't know what R is, but you do know what the height is. Times R squared times 9. Okay, so if you have a pi on either side, you can cancel those out. So I have 12 equals 1/3. Well, 1/3 times 9 is 3. So I have 3r squared. So I just multiplied 1/3 and 9 to get 3. And now I'm going to divide by 3. And then I have, if I go over here, 12 divided by 3 is 4. 3 divided by 3 is 1, or just 1r squared or r squared. Now you have to get rid of that squared, so you take the square root of both sides. So that means your r is 2, but it's asking for the diameter, so you just have to double that. So the diameter is 4. And that's your answer for number 5. For number 7, you have a globe. They give you the circumference. The circumference is 24 inches. So you have to figure out what the radius is to find the volume. I believe that's what they're asking here. Yeah, they're asking what is the measure closest to the volume. So for circumference, remember, is 2 times pi times r. So we have to work backwards to find what r is. So 24 is equal to 2 pi r. So what I'm going to do is I'm going to divide by 2 pi on both sides. And then I'm going to plug this into Desmos real quick. Desmos. So 24 divided by 2 pi is 3.8. So R is 3.8. So now I can use this 3.8 and plug it into the volume formula, which is 4/3 pi r cubed. Okay, so we're just going to plug in 3.8 into 3.8 cubed. Okay, so I'm going to go to Desmos. We're going to plug in 4/3 pi 3.8 cubed is 195.4. 195.4. So what's closest? This 183 I think is closest. That's closer than 234. So okay. Next, number 10. Okay, so for this one here, find the volume of the metal in the right cylinder weight in the barbell in the figure. The cylinder has a 20 centimeter diameter and 2 centimeter thick. The cylinder has an opening that is 2 centimeters in diameter for the bar. Show the necessary work to solve the problem, round to the nearest cubic centimeter. Okay, so for this one here, what you need to do is we're finding two cylinders. We have the larger, so we need the volume of the larger, and then we're going to subtract it by the volume of the smaller cylinder. Okay, so we have two cylinders. We have the big one, the one on the outside, and then we have the smaller one on the inside. So we're going to subtract the two, and then we'll be left with what's in black. So remember, cylinder is pi, oh, sorry about that. It is pi r squared times the height. Now the height is 2 centimeters. That's the same for both of them. So we'll, so the larger, so the radius will be different. So pi times the radius for this, let me erase some of this here. The radius for the larger, the diameter is 20, so that means the radius will be 10. So times 10 squared times 2. So the height is 2. And then the volume of the smaller is pi times the rate, or the diameter is 2 for the smaller, so that means the radius is 1. It's just half times 2. So I'm going to plug these both into Desmos, and then I'm going to subtract the larger minus the smaller. So here we'll have pi times 10 squared times 2. Then we'll subtract the smaller, pi times 1 squared times 2. So this is my answer. So if I even, so that's the larger one, pi times 1 squared times 2. So I have 628.3 and then roughly 6.3. So if I do 628.3 minus 6.3, we get 622. So somewhere around there. So roughly 622. Okay. That was number 10. And then the last one is 20. I don't think I need to erase. Okay. So for this one here, the cylinder and right cone shown have the same radius and the same volume. The cylinder has a height of 12. What's the height of the cone? So for this one here, you have, so the volume for the cylinder, the formula is pi r squared times height. And then the height in this case is 12. Okay, so the volume for this one over here, for the cone, is 1/3 pi r squared times the height. We don't know what the height is, okay? So they said the volume and the radius are the same. So if the volumes are the same, so if this, whatever this number is, equals this number, then this equals this. So that's what I'm going to do over here. I'm going to write an equation. So I'm going to have pi r squared times 12 equals 1/3 pi r squared times h, right? We're trying to figure out what h is. They said the radius is the same. So since the radius is the same and they're on either side, we can just cross them out. Same thing with the pi. The pi is on both sides, so we can cross those out. Like if we were to divide them, they would divide and become 1. So it doesn't matter, we can just cross them out. So now we have 12 equals 1/3 times h. So what I would do is I would divide by 1/3. Divide by 1/3. So if I go to Desmos and I do 12 divided by 1/3, I get 36. So 36 would be my answer for this one. Hopefully this helps. Let me know if you have any other questions.